So, Chris, you are a partner solutions architect.
Yep.
Who is our first partner to go live today?
Our first partner to talk with us is HashiCorp, and they're going to be talking about Terraform.
So HashiCorp do a lot of things. They do Secrets Manager, they do Terraform. What is it about Terraform that is relevant to the EKS land?
Them being able to actually build clusters using Terraform out of the box, just like you do with your CloudFormation templates or your other Terraform manifest, as it currently stands.
So today the experience is customers would go on the console, create a highly available control plane. Then we ask them to do a CloudFormation script and say, bring your worker nodes and connects to the control plane. Which part of it is Terraform now?
So I think I would pass that off to HashiCorp to actually talk through that and demo what they have.
Yeah, we'd love to. Thank you.
All right, take it away.
All right, so my name is John Benson. I'm the head of Worldwide Solutions Engineering at HashiCorp and have had the privilege of working there for a bit over 3.5 years now. HashiCorp Terraform does a lot of things. We'll talk about those in a minute, but the biggest piece is how does it integrate with EKS? How do we build out this partnership with Amazon to ensure that all the services that are released do have day 1 support, day 0 support, and are available to both the Terraform users and the Amazon users. Company overview. We were founded in 2012 by Mitchell Hashimoto and Armand Dadgar. A quick brief on the mission. We enable organizations to provision, secure, connect, and run any infrastructure for any application. You may know us by these different open source projects that we've created throughout the years, starting with Vagrant a bit over 6 years ago. We're very much at the development layer, and we moved up the stack with Packer into creating immutable artifacts for infrastructures and applications. Terraform, which we'll talk about throughout this presentation. You'll see a quick demo of how Terraform can enable you to more efficiently manage your infrastructure. Vault to secure that infrastructure and applications on top of it. Console to connect it, and then Nomad to deploy applications. As you look at the stack, this is the way we view the world, where there is this infrastructure layer at the bottom, which is storage, network, and compute that's everywhere. It's very heterogeneous these days, and so you need a common workflow for how to manage your IaaS, PaaS, and SaaS resources that comprise your infrastructure. Vault sitting there in the middle, securing, Nomad on top, and Console to connect everything. Importantly, the way that we view the world is that you don't need to use our entire stack. It's not a platform. They're modular and composable and built so that they can plug into the ecosystem that you're familiar with. And so if you're using Kubernetes instead of Nomad, that's fantastic. We have great integrations with Vault and Terraform, which we'll talk through. Terraform, takeaway from what it solves for is scale. So how do you achieve the scale that allows you to efficiently manage your infrastructure and increase the velocity of your application delivery? Heterogeneity, embracing it. IaaS, PaaS, and SaaS. It's everywhere. There's newer and newer technologies coming out. How do you adopt that immediately and quickly so that you can take advantage of the latest and greatest like EKS? And then reusable blueprints. We preach infrastructure as code. You'll see it throughout all of our projects. We want you to be able to collaborate on your code, iterate on it, audit it, version it, just like you do with every other piece of application code you touch. You want to be able to create those efficiencies. Finally, the way Terraform works, and then we'll get to the demo, is it has a core graph engine which manages all the different dependencies of resources that it can manage. It has, of course, AWS was the biggest provider that we had dating back quite a few years ago, and continued support for that. But that's just infrastructure as a service, which we can leverage. But we also have Kubernetes now that we want to be able to manage as code as well and get the same efficiencies that we see in provisioning AWS infrastructure in a snap, as well as configuring that infrastructure and the services that run on top of it. So with that, we'll quit with the slides and get to the demo. Where we want to start is I've pre-provisioned an EKS Kubernetes cluster, and I did that. It takes around 10 minutes, and so rather than you guys watching Terraform at work, we'll get to a more exciting use case of once I have my cluster up, what can I do with it? How can I still leverage Terraform to manage things within that Kubernetes cluster? And so to get a quick status, we'll see what different resources that we have and that they're healthy. This is just a vanilla Kubernetes cluster. It has different pieces that are running on top of it, and so this was just a one-shot provision that created the Kubernetes cluster using EKS, and then also deployed the different the different dashboard resources that are going to be running on top of it. And so we can see all the different services that are there. Our goal and what we're going to attempt to do today is deploy more infrastructure or applications on top of this pre-existing Kubernetes cluster. So this is just kind of the bare bones cluster that we see. What we have here is two different workspaces, and Terraform, you can segment your infrastructure into different workspaces, which allows you to take this this massive infrastructure, almost a monolithic infrastructure, and break it down into micro infrastructures, if you will, so that the different teams that are involved in managing infrastructure only have to worry about their piece of the infrastructure, and they can have these contracts with the other components of the infrastructure to still provision. So in our case, you can look at the provision cluster workspace as one that an operator would use to manage their EKS Kubernetes cluster. And so with that, you don't just go into a dashboard and click create and all of a sudden everything's good. There's no silver bullet with creating infrastructure like that. There's a lot of dependencies. These dependencies are, how do I authenticate? Assume role. What are the different permissions that Kubernetes needs as well as those that are interacting with it? The different policies that we then want to be able to give those different roles. Going down the security group rules. This is just basic stuff, but generally, rather than you having to point and click and create these firewall rules or managing it through other scripts in that, you can use Terraform to template it. And finally, about 15 lines of HCL is going to be your EKS cluster, and this manages all the complexity of Kubernetes. All you have to do is pass in that role ARN, some security group IDs, and the subnet that was pre-created in our VPC Terraform template file, which is just a bare bones network. And voila, I have a Kubernetes cluster. Now, that's pre-created. I also had some worker nodes so that I can actually schedule pods and containers on top of that. Very similar in nature, where I need the IAM role, security groups, the data source to be able to fetch the latest AMIs that Amazon is maintaining for us, and then the launch config and ASG to be able to manage the desired capacity. And so then right around 100 lines, and I get my worker nodes as well. So those are the main components of it, and that's where I ended up with here with my Terraform apply. And I have some helpful outputs there, but what we want to do is now leverage that infrastructure. And the way we can leverage it is by looking at this deploy pods workspace, where what I'll do actually is I'm going to kick this off and I'll walk through the Terraform template, where I start within a init. So I initialize and say, all right, what providers do I need? In this case, we're leveraging the Kubernetes Terraform provider, which is how I can configure Kubernetes clusters and manage it in the same way I would manage my Kubernetes infrastructure. And then I'm going to run a plan. So what's it going to create? Starting at the bottom here, it's going to add 4 resources. We're going to create the Kubernetes service, which is an Nginx service. It's a load balancer for us. We're going to create the Kubernetes pod, which is running the Nginx image that I defined through a variable. The Kubernetes namespace, so I want to segment this from default or any of the system namespaces. I want to create my own namespace for this specific demo. And then I also want to create an AWS auth worker node join. So by default, the node workers need to be able to join and have the policy within Kubernetes to do so. So I create that through a config map, again, as code. And so I'll go ahead and apply this. I'm going to auto approve it for the sake of time. And that should go pretty quickly because it's just interacting with the Kubernetes cluster. Now, what I have is a remote state, and this is kind of my API contract between different workspaces where I can consume information from the outputs. And so I don't need to know anything about the operators or how they created this Kubernetes cluster. All I need to know is things like the endpoint or what's the certificate that was used, and they can expose that to me through Terraform outputs. So then what you can see is that I'm leveraging that through various resources. And so my role ARN in my config map is going to be interpolated from the data source, which is my Terraform remote state. And so again, Terraform is a huge graph engine. It manages all the different dependencies. So if I were to change the, let's say, role, the IAM role ARN that was being used, in the provision cluster workspace, I can then automatically have it update my other workspaces for me. moving on, my Kubernetes namespace, and so this is just a simple resource with metadata, labels, annotations. In this case, we have examples. We'll see to prove I didn't pre-create this. Kubernetes pod, so Nginx, label, the container I'm passing in through some sane defaults in my variables here. And then finally, my Kubernetes service, so that I can actually find it on port 80, pass that through to 8080, and view, hopefully, my Nginx. So when we go back here, we see that it did, in fact, create those 4 resources. And there's some helper commands here. So similar to my namespaces command I ran on the other terminal, what we should be able to see is the same ones, but now we have a new EKoSystem day namespace. And so rather than actually going through all those commands, what we also have is a UI that I can leverage that Terraform also spun up for me. So if I run that proxy and I grab this, assuming things worked well, which it did, that's great. I also am going to need a token, so I have a helper command to grab the token of the admin that I created on that Kubernetes cluster. I'm going to go ahead and copy, paste. All right, wonderful. So now I have a Kubernetes cluster, which was provisioned by my operators. I have a developer, which may be just responsible for managing Nginx. They don't need to know how to provision an EKS cluster, although it's very easy now. They just need to interact with it and deploy resources on top of it. And so in this case, if I look at my namespaces, those are the ones that I would have expected. The nodes that I have available are the 2 nodes that I provisioned with the Kubernetes cluster. Those are my workers. And if I drop into my EKoSystem day namespace, what I want to see is, did I actually create a pod? I did create a pod. It's this Nginx demo, and it's been running for 2 minutes. So I can hook this up to my CI/CD pipeline and manage my Kubernetes pod templates, anything I want to as code, and have it all mesh with my existing infrastructure. Going down, if I want to see the service, I did in fact create that service. And if this actually worked, yes it did, so I get Nginx running. That was all with 1 provision by the operator and a 2nd provision by the developer. And so it's very simple, it's repeatable. If I wanted to do this in dev locally, I could have smaller instances. If I want to promote that to staging and production, it's all very simple because I use the same workflow that I use with any other code that I run through a version control system. And so finally, the last piece that we had created that was also as code was our config map. It's actually not default. It's going to be KubeSystem. And therein, I have my AWS auth that I mapped out there. It interpolated the ARN from what it grabbed from that output. And so all of this works well. If I want to make changes, I can go back to Terraform, run a Terraform plan. It manages all the state, and so unless someone changes something, someone deletes something in the console, it's not going to change anything. If I change something in my Terraform template, it'll then show as a change in my plan that I can choose as a human whether this is something I want to do. And so that's how Terraform works, and that's how it works with EKS. Day 0 support, which is very exciting for us. We'll continue with that partnership to ensure that we have the support for all the new exciting services that Amazon releases.
Thank you.
Thank you.
Thank you.